Hello everybody, welcome to High School Tutoring. So this is going to be a channel that I created. I'm Manny. Some of you might know me if you're watching this from ATHS. But I'm basically creating this as a way so I can kind of help people out with topics that they might not understand as much. So like if we have, let's say, someone who doesn't understand a specific physics topic, I would probably have a video up explaining how I do it and maybe some good tips on figuring it out and some other stuff like that. So let's begin with what we're learning today, which is going to be Freefall dropped. So specifically, we're learning about drops specifically of Freefall. So when we are learning about this, we're looking mainly at G, which is gravity, or 9.8, sometimes 1, depends, meters per second squared. Ignore my handwriting, it's pretty bad. But the reason I have the 1 in parentheses here is because usually you see when you Google what is the force of gravity, it's 9.81. But in this scenario, we're using 9.8 just to make the numbers a little bit easier. And okay. So when something is dropped, you usually think of it as its starting point is always going to be 0. So if we're looking at V0, which is going to be our initial velocity, like right as it's dropped, it's always going to be 0 meters per second when we're working with drop problems. So if we're looking at that, I'm going to have a little diagram showed up here where it's going to explain well, I'm not going to have a diagram up here. I'm just going to draw it. So let's say this is 0. This is going to represent our velocity. So this is going to be our initial velocity, and then we'll just have it going down. If we are increasing our velocity by 9.8 meters per second squared, we are going, so let's say if we're at 1 second, so this is 1 second, this is 2, and then etc. going down until it hits the ground. So we have 1, we have 2 seconds, and we have our gravity. So we can find out how much our velocity increases by then. So if we're finding our V final, let's say for 1 second, how fast would this theoretical rock or ball be going at 1 second? So we would do the equation V final equals V0 plus GT. Ignore my terrible handwriting again, my apologies. So we have V0, which in our scenario is going to be 0, so we can just cross that out. We're going to ignore that. So if our G, if we correspond up here, is going to be 9.8, and our time, as we've shown here, is going to be 1. So if we just quickly put that into the equation, we're basically solving for V final equals 9.8 times 1. That's how this is going to work. Specifically, if this was thrown down or thrown up even, this is going, the V0 would 100% be included because V0 would not be 0 in this scenario, which it is. So we could solve for this, and 9.8 times 1, pretty simple. This looks like VT, I'm just going to change that. And that's going to be 9.8. So there you go. Now we have our 9.8 meters per second on the V final. But let's say you wanted to solve for 2, 3. In this scenario, it's pretty easy, so same situation. So we're just going to do V final equals, and we have the formula set up, so just GT in our scenario because V0 is 0. We're going to have 9.8 times 2 instead. And so realistically, this is what it's going to look like. Specifically, the problems might be a little different. It's going to be a little confusing at times, but bear with me, it's going to be much easier. So yeah, we have this now specifically, and we can just solve for it now. So that's going to be, so 9.8 times 2 is 19.6, so we can just have that, we can just have 19.6, and there we go. So that would be meters per second, and that would be meters per second. So now let's just clear this example out. I'll leave the diagram up except for the examples. Hopefully you are taking notes specifically, but I'm gonna leave everything there. And okay, so let's get to solving. So here is our scenario today. Jack drops an apple from rest, so off of a 25-meter roof. How long will it take for the apple to hit the ground, and how fast is it going when it strikes the ground? So in our scenario here, in our scenario today, we are looking at an apple. Jack drops an apple from rest. So that is going to give us a key thing. So we'll write our givens for today's example. And now that we know it's from rest, so that v naught will equal 0. All these problems are going to have 0 meters per second, or not meters per second squared, my apologies. It would just have meters per second as v naught, so we're just going to leave that there. And then we're looking for, oh god, what am I doing? Okay, and we're looking for off a 25 meter roof. So 25 meters, that's going to be our displacement. Displacement is going to equal 25 meters. So how long will it take for the apple, so we're going to underline that one again, to hit the ground? So it's going to take how long is our keywords today. How long is one of our key phrases that we're going to be using. How long will it take for the apple to hit the ground, and how fast is it going when it strikes the ground? So our unknowns for today are going to be, so I'm just going to write UNK, so hopefully you can understand what I'm trying to go with that. And our unknowns for today is going to be time and v final. So if we're using this, how long, pretty self-explanatory, that will translate to time. And then how fast when it strikes the ground, that's going to be our final velocity, so that would be v final. So let's get to our first formula. We're going to solve for time because it makes it easier when solving for v final later. We could do flip-flop, but it's a very big hassle and the equations get confusing. Just budging in here to say that when I mean like by being difficult problems, no, it's not very difficult. It's just a different way to solve it. In Thrown Down, I'll be able to show in the next video when I do Thrown Down, I'm gonna be able to show how you can do it in different steps, and it's just a couple things. It's gonna be multiple parts. It's crazy, all right. So we're just gonna solve for time, as it is the first question. We'll just solve them in order. So for our time, for our formula, since we don't have v final in this specific scenario, we are going to be using displacement. So displacement is our distance, or in physics, displacement is away from the base. So let's say if I move to the right 5 meters and then I move back and I move left 2 meters, my displacement would be 3 because I'm still 3 meters away from where I originally started. So ignore my brother in the background, just ignore him. Okay, so now we can continue. So now the equation that we're going to be using is the same as in the other equation. I have v naught t plus 1/2 gt squared. So instead of a, as we usually use as acceleration, since g is our current acceleration, because meters per second squared, we will just have it as g, because just to make variables easier. And so now that our v naught is 100% 0, as we've confirmed in the problem and inside of our example, we can cross this entire term out of the equation. So we're just left with d equals 1/2 gt squared. So now we have 1/2 gt squared. How do we get t by itself? So first off, we're going to times both sides by 2, and that would be 2d equals gt squared. Now that we removed that 1/2 from the equation, or we've moved it to the other side instead, realistically, we could divide by g just to make life easy. So now we have 2d over g equals t squared. Now obviously t is not t squared, so we're gonna have to find the square root of the entire thing, and no difficult problems or anything. We're just gonna find the square root after. So we're going to solve for 2d over g first, and then we'll find the square root of whatever that is. So let's plug in. Now that we know our first equation, we can plug in specifically. So we'll have t equals 225, because that is our displacement for today. So 225, ignore my button pressing, is a thing, over g, which would be 9.8. Sorry, it looks a little messy, but just gonna have to bear with me. So you can write this along if you want to, or you can just use this to help you out in understanding, so you can do it yourself. So 2 times 25 would be 50 over 9.8. Remember, we leave this there. Also looks like a 3, so I'll just do that, just so you guys know. And then make sure to keep the square root, because that's what we're gonna need. So let's grab our calculator, which I have in my hand currently. We could do 50 divided by 9.8. To shortcut it, If you guys wanted to, you could put 50 divided by 9.8 in parentheses and then put that all in a square root. But I'm just going to do it in step by step. So we get around 5.1 after we divide. And then we find the square root of 5.1. And then now we get 2.25. So our answer for this equation is 2.26 or 2. And that would equal t. So 2 seconds equals t. That is going to be our answer for the first problem. So now we solve for the second one. We already had this equation here. V final equals v naught plus gt. So we found out it will take the apple 2 seconds to hit the ground from 25 meters, or 25 meters up. So now we just find the v final of that. Pretty simple. So now we don't have any v naught, so it's just gonna be gt, and that will be v final equals 9.8, and then 2. Just pretty simple. It's not gonna be the exact answer because 2.26, but in our scenario, it will just work. It will work just fine. And then v final multiply 9.8 times 2, 9.8 times 2. We get 19.6. I'll also have the exact answer here. So 19.6. But for sig figs, we want 20. So we're ending with 20 meters per second. Very simple there. It makes a lot more. This should make a lot of sense. If it doesn't, just feel free to leave me some questions in the comments and I'll reply to you. So let's continue now. Really quick, I'm just going to show the exact answer. So the final equals 9.8 times 2.26. So we'll just have that there, and I'll solve really quick. And okay. So instead of 19.8, instead of 19.6, we get 22.15, or 22 meters per second. Both of these are perfectly viable solutions, except I think our physics teachers at ATHS are definitely going to prefer 20 because we want to find with sig fig specifically. And if you wanted to find displacement, very simple. Just plug into this problem or any other problem that uses all the variables we found. So here are our answers, either 22 or 20, and either 22.6, or I just circled the wrong thing, please excuse me, 22.6 or 2 seconds. So yeah, thank you for watching, and I hope that this video has helped you out a little bit to understand dropped, and yeah, thank you for watching, and I'll see you guys in the next video. But goodbye.